Welcome to Understand the Math. In this video, we're going to learn about the three types of solutions that can occur for a system of equations with two variables. You'll learn how to recognize each type graphically and how to classify them. We'll then walk through some examples to see what the equations look like for each type of solution. Let's get started. A system of equations with two variables can have one of three different types of solutions. The first type is when a system of equations has no solution. I've graphed these equations. The first one is in green, and then the second one is in red. When a system of equations has no solution, the graph of the equations are two parallel lines. The lines never intersect, and so there is no solution. The two lines have the same slope and a different y-intercept. This type of system is called an inconsistent system because it has no solution. Let's now look at the second type of solution you can get. That would be one solution. I've graphed these two equations, one in green and one in red, and you can see that they have one point of intersection, and that's where the one solution comes from. The two lines intersect at this point, and the two lines have a different slope and a different y-intercept. This type of system is called a consistent system, and it's also called independent. Let's now look at the last type of solution that you can get. This type is when you get infinitely many solutions. The graph of these two equations is actually the same line. The two lines are identical, which means that every point on the line is a solution, which is why there are infinitely many solutions. The two lines have the same slope and the same y-intercept. This type of system is again called a consistent system, and it is dependent. When you have a system that has infinitely many solutions, the equations are actually multiples of each other, and that's why they are the same line when you graph them. Let's now look at some examples. I have three examples, and in each example, we have a system with two equations and two unknowns. We're going to solve the system. We're going to state the number of solutions and then state if the system is consistent or inconsistent. And then if the system is consistent, we're going to state if it is independent or dependent. Let's look at our first example. I'm going to solve this example using the substitution method. I have a video on that if you need to review that concept. Let's take our first equation and let's solve this for x. So we're going to write this equation as x is equal to 5 minus 3y. Now we're going to take this value for x and substitute it into our second equation. This gives us 2 times 5 minus 3y plus 6y is equal to 1. Now let's go ahead and simplify our left-hand side. This is 10 minus 6y plus 6y is equal to 1. The 6y's cancel out, and we're left with 10 is equal to 1. Now, 10 can never equal 1, so this tells us that this system has no solution. And because it has no solution, it is called inconsistent. Before we go on to our next example, I want to point one more thing out. If we solve both of these equations for y, our first equation becomes y is equal to minus 1/3 x plus 5/3, and our second equation becomes y is equal to minus 1/3 x plus 1/6. When we have no solution, our equations have the same slope, but they have a different y-intercept because they are two parallel lines. Let's now look at our second example. I'm going to solve this example using the elimination method. I'm going to take this first equation and I'm going to multiply everything by 2, and then that way both of our x's will have a 4 in front of them. This equation becomes 4x minus 6y is equal to 18, and then we just copy down our second equation, which is 4x plus 3y is equal to 9. Now what I'm going to do is I'm going to subtract these two equations because the x's are going to cancel out, and this gives us a minus 6y minus 3y on the left, and then 18 minus 9 on the right. This gives us minus 9y is equal to 9. To get y by itself, we will divide both sides by minus 9, and we get y is equal to minus 1. I'll highlight that, and now we need to find x. What we're going to do is we're going to take this value for y, and we're going to go back into either of our equations, plug it in, and then find x. I'm going to use the first equation, and I'm going to write it down up here on the right. 2x minus 3y is equal to 9. And we're going to take the y that we just found and plug it in up here. This gives us 2x minus 3 times minus 1 is equal to 9. So we have 2x plus 3 is equal to 9. If we subtract 3 from both sides of the equation, we have 2x is equal to 6. And then if we divide both sides of the equation by 2, we get x is equal to 3. This system has one solution. So let's go ahead and write that down. It has one solution. And that solution is 3 minus 1. Because it has one solution, it is called consistent. And it is also called independent. If we solve both of these equations for y, we're going to get y is equal to 2/3 x minus 3. And then the second equation becomes y is equal to minus 4/3 x plus 3. Notice that the slopes of these two lines are different and the y-intercepts are different. And when that happens, the two lines intersect at one point and you have one solution. Let's now look at our last example. To solve this example, I am going to use again the elimination method, just like we did in the second one. And I'm going to take our first equation and I'm going to multiply it by 3. That way the x's will both have a 3 in front of them. This gives us 3x plus 12y is equal to 24. And then we'll copy down the second equation, and it's exactly the same thing. We can subtract these equations, and we end up with 0 is equal to 0. Whenever you get something like that, that means that we have infinitely many solutions. Because we have infinitely many solutions, the system is called consistent, and it is also called dependent. If we solve these equations for y, we're going to get y is equal to minus 1/4 x plus 2. And we get that for both of the equations, because they're the same equation. The slope is the same, and then so is the y-intercept. And whenever this happens, we have two identical lines. And that's it. Now you understand that a system of equations with two variables can have no solution, one solution, or infinitely many solutions. You also now know how to recognize each type graphically and then classify them correctly.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.